Welcome to Impossible Ancient Engineering. Episode 1, Persia. Persia wasn't a single landscape. It stretched from snow-covered mountains to fertile plains, from dense northern forests to some of the driest regions on Earth. Different landscapes created different challenges. And every challenge demanded a different solution. Some of those solutions were so effective that we still study them today. The first part is the river no one could see. Imagine arriving in a town where there is no river, no lake, and no visible spring. Yet vineyards grow. Fruit trees cast shade. Fields are green. Families have lived here for generations. So where does the water come from? The answer isn't in front of you. It's beneath your feet. High in the mountains, winter snow and seasonal rain slowly seep through layers of rock, collecting in natural underground aquifers. The water already existed. The challenge was never creating it. The challenge was taking it over long distances without losing it to the desert. Most civilizations transport water above the ground. Persian engineers asked a different question: what if the water never had to see the sun? From above, you notice something unusual. A line of perfectly spaced circles stretches across the landscape. At first, they look like abandoned wells or strange marks left behind by time. They aren't. Those shafts lead to one of the greatest engineering achievements of the ancient world. A qanat. Calling it a tunnel doesn't do it justice. Digging the tunnel was only half the challenge. The real challenge was invisible. The slope had to be almost perfect. Too steep, and the water would erode the tunnel. Too shallow, and it would never reach the town. No satellites. No GPS. No laser instruments. Only careful observation, geometry, experience, and an extraordinary understanding of the landscape. Kilometer after kilometer, they carved a hidden river beneath the earth. Gravity became the engine. The mountain became the reservoir. The earth became the pipeline. Protected from the scorching sun, the water could travel for tens of kilometers before emerging exactly where people needed it. Some qanats have supplied entire communities for centuries. Remarkably, some still carry water today. Take a moment and think about that. Look around the room you're sitting in. How many things around you will still be working 2,000 years from now? Water was no longer the problem. But surviving the climate meant solving another one. Here is another genius engineering: the city that learned to breathe. Water solved one problem. But another remained. Heat. Not the kind that simply makes you uncomfortable. The kind that can shape the way an entire city is built. Today, every summer seems hotter than the last. Air conditioners run day and night. Power grids struggle under record demand. The more we try to cool our buildings, the more energy we consume. It feels like a modern challenge. It isn't. More than 2,000 years ago, engineers in Persia faced the very same question. How do you keep a building cool without electricity? Their answer wasn't hidden underground this time. It was already moving all around them. The wind. Walk through the old city of Yazd, and one feature immediately catches your attention. Tall towers rise above rooftops in every direction. At first glance, they look like chimneys. They aren't. They're machines. These towers are called badgers, or windcatchers. But despite the name, they don't create cool air. They simply know where to find it. Each tower is carefully oriented toward the prevailing wind. As the breeze enters through openings at the top, it travels down narrow vertical shafts. At the same time, warmer air inside the building naturally rises and escapes through other passages. The entire structure begins to breathe. Some designs became even more sophisticated. Cool water flowing through underground qanats passed beneath the building. As fresh air moved across that water, it lost even more heat before entering the living spaces. No motors. No compressors. No electricity. Only wind. Water. Gravity. And an extraordinary understanding of airflow. The wind became the architect. The tower became the machine. The house became an air conditioner. What's remarkable isn't that these towers cooled buildings. It's that they did it using almost no energy at all. Perhaps ancient engineers weren't asking, how do we overpower nature? Perhaps they were asking a far better question. How can nature do the work for us? By now, a pattern is beginning to emerge. The qanat never fought the desert. The badger never fought the heat. Both succeeded for the same reason. They worked with nature, instead of against it. But water could do far more than keep people alive. If you learned how to control its movement, it could power an entire city. Next is the river that went to work. Water can do many things. It can carve valleys. It can shape mountains. It can give life to entire civilizations. But in ancient Persia, it learned how to work. Most cities are built beside rivers. Shushtar was built with one. At first glance, it looks like an ordinary river flowing through an ordinary landscape. But look a little closer. The water isn't simply following nature anymore. It's being guided, divided, slowed down, accelerated. Every change has a purpose. Engineers diverted part of the Karun River into a carefully designed network of canals, tunnels, bridges, and weirs. Some channels became deliberately narrower. Not by accident, but because squeezing the same amount of water through a smaller space makes it flow faster. Faster water carries more energy. That energy turned into enormous milestones, grinding grain for entire communities. No engines. No fuel. No electricity. Just the steady force of a river that never stopped moving. But here's the part that makes the system truly remarkable. The water didn't stop after powering the mills. It continued its journey, flowing into an irrigation canal, watering orchards and farmland, before finally returning to the river. Every drop had more than one job. Think of a mechanical watch. Inside, hundreds of tiny gears work together with extraordinary precision. Most of them seem insignificant on their own. Remove just one, and the entire mechanism stops. Shushtar worked the same way. The canals depended on the tunnels. The tunnels depended on the bridges. The bridges depended on the weirs. The mills depended on all of them. It wasn't a collection of impressive structures. It was a single machine. Perhaps that's the greatest lesson hidden inside Shushtar. The engineers didn't create energy. They understood it. They observed how water behaved, then designed a system that allowed nature to do the hardest work itself. By now, the pattern is impossible to ignore. Gravity, wind, water. Three completely different problems. Three completely different solutions. One remarkably consistent way of thinking. Don't fight nature. Learn from it. Because the final masterpiece wasn't built with moving water, it was built with stone. And last but not least, the empire beneath the stone. For a moment, forget the columns. Forget the gates. Forget the kings. Because the greatest engineering achievement at Persepolis wasn't the part people came to admire. It was the part they rarely noticed. Before a single palace could rise above the plain, the ground itself had to be transformed. Engineers carved part of a mountainside and built the rest by hand, creating an immense stone terrace that stretched for hundreds of meters. Everything that followed depended on that foundation. But building upward created another problem. Rain. Water has destroyed more cities throughout history than many armies ever could. Before they built the palaces, the engineers solved the rain. Hidden beneath the terrace was an intricate drainage system. Carefully carved channels carried stormwater away from the foundations, protecting everything above. Most visitors walk across Persepolis without ever realizing that one of its greatest engineering achievements lies beneath their feet. Then your eyes move upward. Those famous double-headed bulls standing above the columns seem like works of art. They are. But they were also part of the structure itself. Massive cedar beams rested across those stone capitals, allowing enormous roof spans while distributing the weight safely across every column. Here, beauty wasn't added after engineering. Beauty was the engineering. Now look even closer. Not at the buildings. At the people carved into them. The staircases of Persepolis don't celebrate endless battles or scenes of destruction. Instead, they show delegations arriving from every corner of the empire. Different clothing. Different languages. Different traditions. Every figure was carved with remarkable attention to detail, preserving identities instead of erasing them. And beneath those stones, another story waited. When archaeologists uncovered thousands of clay tablets, they didn't discover myths or legends. They discovered records. Lists of workers. Travel routes. Food distributions. Skilled craftsmen. Administrative accounts. Even records show women receiving rations and holding important roles within the imperial workforce. Suddenly, Persepolis became more than a monument. It became a window into the lives of ordinary people. 25 centuries ago, this place wasn't silent. Water flowed through carefully planned gardens. Trees cast shade across the terraces. Engineers, stonemasons, artists, administrators, and visitors from across the empire passed through these gates every day. It wasn't simply a palace. It was a living system. Throughout this journey, we've watched gravity move water. We've watched wind cool buildings. We've watched rivers power machines. And here, we've seen something even more remarkable. None of those achievements happened because ancient people had better technology. They happened because they asked better questions. How do you bring water across a desert? How do you cool a city without electricity? How do you turn a river into a machine? How do you organize thousands of people to build something that outlives them all? Different problems. Different solutions. The same human curiosity. History isn't just a record of the past. It's a library of ideas. Some of those ideas are thousands of years old. And some of them may still shape our future.